We've covered a lot of ground in this section using just one terminal operation for each. Now it's time to see why stream processors are such a welcome feature as I show you other terminal operations you can use. This slide has them categorized by the result. Some are designed to find matches, most of which are targets for a predicate lambda expression. Some are designed to transform stream data into a collection or some other reference type. Others aggregate information to count elements or find a minimum or maximum value and don't take arguments. The primitive streams have average and sum as well, and a summary statistics operation which gives you count, min, max, average and sum in one result. A couple of these operations return a special type called an optional. I have a video coming up on the optional class, and of course we've talked about for each, but there's also a for each ordered operation. A reduction operation is a special type of terminal operation. Stream elements are processed to produce a single output. The result can be a primitive type like a long in the case of the count operation. The result can be a reference type like optional or one of the statistical types I'll be covering shortly. It can also be any type of your choice, such as an array, a list, or some other type. I want to start by looking at some of the statistical reduction methods. I've created a new project and called it Stream Terminal. I'll use an int stream in this example. Like any stream, I can use the iterate method on it. Here I'll pass 0 as the seed. I will make the condition less than equal to 1000 and I'll increment by 10 each time. I'll use the summary statistics operation and print the result. I've again used type inference, and you can see from IntelliJ's inlay hints that the result is inferred to be an int summary statistics type. I'll run this and see what I get. You can see that the type gets printed out, so int summary statistics with data about this stream. In this process I had 101 stream elements, the sum was 50,500, the minimum value was 0, the average is an even 500, and the max value was 1000. That's kind of a useful operation. Let's try this code again, but this time I'll change the number I'm incrementing by from 10 to 3. Running that. I get a different set of stats, I have more elements, and the statistics are different. Using this operation would be a good place to start when you get a set of data and you want to try to start understanding it. Remember, if you have a stream of instances, you can stream any data field to an int or double stream using one of the map operations and then use this terminal operation to give you a quick overview. You can also individually call the count, sum, min, max and average terminal operations, but I'll show you these after I cover the optional class, which is returned from several of these methods. I'll show another example of code to evaluate leap year data between the years 2000 and 2025. I'll set up a variable leap year data and int stream. I'll use iterate with 2000 as the starting year and 2025 as the maximum year. I'll increment each next year by 1. A leap year is evenly divisible by 4, so I'll use the modulus operator to filter. If I mod 4 is equal to 0, then it's evenly divisible by 4 and a leap year. I'll get statistics first and print those out. If I run this, I can see that there are 7 leap years between 2000 and 2025, with 2000 being the minimum year and 2024 being the maximum. This is a good place for the peak operation because it might be nice to see what those years are. I'll insert that after the filter operation but before summary statistics. Running that, I get the 7 leap years printed out as well as the summary. You can see that peak is useful when you're doing reductions. It gives you a window into what is happening. I can use terminal operations to return information about the aggregated dataset. The methods shown on this slide have no arguments. They all return numerical data, either directly or in specialized types, to hold that data. I'll show examples of the rest of these after the optional video. Before that, I want to talk about methods for matching elements on a specific condition. There are 3 terminal operations that let you get an overall sense of what your stream elements contain based on some specified condition. These all return a Boolean and take a predicate as an argument. You can think of these as ways to ask true or false questions about the dataset, the stream, as a whole. The all-match operation returns true if every stream element meets the condition specified. Any match returns true if there is at least one stream element meeting the condition. Lastly, none match returns true if no elements can be found that match the condition. I'm going to quickly create a seat record again. I'll generate a custom constructor next, and this will just have two fields, row marker and seat number. Instead of passing false as the isReserved value, I want to pass a randomly generated boolean. I'll replace false with new random and call next boolean on that. Getting back to the main method, instead of creating a stream, I'm going to start by creating an array of seats. I'll start with a new seat array with 100 null references. This seat creation code is basically the same as I used before in the intermediate operations video, so the row marker will be A through J in this case, depending on the value of I, and the seat number itself will be 1 through 10. I'll print these out to confirm the data is what I expect it to be. If I run this code, I can see confirmation that my seat rows start with A and end with J, and that the seat numbers are a number between 1 and 10. I can also see the random nature of the seats that are reserved. Okay, I'm going to comment out the statement that prints the seats because I don't want to see them printed each time I run this code. I'm going to use this array as the source of my streams. I want to use the count operation first to see how many reserved seats I have total. The other statistics aren't that interesting in this case. I'll start with a long variable, which is what the count operation returns. I'll use arrays.stream and pass my seats array to create a source. Next, I want to count only reserved seats, so I'll use seat : is reserved in my filter operation. I'll use the count terminal operation, then print out the number of reserved seats. Running that code, I should get a different count each time I run it, since I'm randomly reserving these seats. Next, I'll demonstrate each of the matching terminal operations. For the first, I'll create a Boolean variable called hasBookings and assign that to the result of my stream pipeline. The source will again be my seats array. I don't have to filter with an intermediate operation when I use these operations because the predicate is built in. I can call any match, passing it the same predicate, the method reference. I will print this out. This operation just checks to see if there's at least one element that's reserved. Running this, I can see that it's found some matches, and that has bookings equals true, which you'd expect for the randomly generated reserved field. I'll copy that last segment of code from lines 32 through 35 and paste a copy below. In the copied code, I'll change hasBookings, my local variable name, to fully booked. I'll change the terminal operation anyMatch to allMatch. Lastly, I'll change my print statement to print fully booked. Running this code, my reservation count will change, but hasBookings should still be true. Fully booked though will be false, since the random process I'm using to book seats is unlikely to reserve every seat. Similar to allMatch is noneMatch, so let me copy those last couple of statements and paste a copy below. This time I'll change the local variable to be event washed out. I'll change allMatch to noneMatch, and I'll print event washed out. Running this code, you can see that event washed out is false as well. Like fully booked, the random generation is likely to return several booked seats. I will go back to the seat record and comment out that call to the canonical constructor. I'll copy and paste it below, changing the random part to just true, meaning every seat will be reserved. This means the event is sold out, so if I run this, I get reservation count is 100 and hasBookings equals true. Now, even though fully booked is true, event washed out is still false. I'll change the seat constructor one more time, passing just false this time, running this code. I get a different story. There are no reservations, hasBookings is false, fully booked is certainly false, and event washed out is true. These three conditions cover every scenario, and allow you to use stream terminal operations to get information about all elements in that stream. Since this video is getting a bit long, and I still have 2 more types of terminal operations to cover, I'll bring this to a close here. I'll talk about the transform and process terminal operations next, but first I want to set up some code that I'll be using for the remainder of the lectures, and that will be used in a challenge for you on the terminal operations we've looked at so far. You can use the next video as an additional challenge if you feel like you'd like to approach it that way, or you can follow along. You can also just skip ahead and import the code that I'll be creating in the challenge video on terminal operations.